In this video, we will be working on a mid-2012 MacBook Pro 13-inch that doesn't power on. I already took the motherboard out so we can inspect to see why it's not powering on. The first thing I want to do is plug the charger in to see if we have a green light on the charger. Right now, the charger is plugged in. On the power meter, on my power supply, I'm seeing 0.1 amp draw. That's not good, and that means that the motherboard is not turning on. 3.42 volts is partially responsible for turning the green light on. If 3.42 volts does not exist, it doesn't make sense to troubleshoot any other area of the board unless we fix this voltage rail first. If I look at the charger, I do not see a green light on the charger. Now, what makes the green light? The first thing I'm going to do when troubleshooting for a green light is to look at the MagSafe DC power jack circuit, which is right over here. So voltage enters in from the charger, 18 or 19 volts goes through the fuse, and it becomes PP18V5 DC in con. PP18V5 DC in con, let's see where this is going to. This is needed to make 3.42 volts, and 3.42 volts is needed for this circuit to work. If you look here, we have an AND gate. An AND gate means that 1 and 2 must be present in order for the signal to go in. If we do have 3.42 volts, that means that this circuit is working. 18 volts is being converted to 3.42 volts. That's good. If we do not have 3.42 volts, we need to troubleshoot the circuit to see what's causing the problem and why 3.42 is not being generated. Considering that we have 3.42 volts, we also need SMC DC AC OK, because this is what is needed in order to open the gate to let in the voltage. Now, where is SMC DC AC OK coming from? Let's search for it. I missed it. Okay, so right here, SMC DC AC OK is equal to charger AC OK. So we need to look for charger AC OK. And charger AC OK is coming out of U7000. If we do not have charger AC OK, that means we have to troubleshoot the circuit. Anything in the circuit can cause charger AC OK not to work. Now, do not let this circuit diagram intimidate you. The circuit is simple. 18 or 19 volts comes in from the charger, and using the buck converter and the IC, it makes out PP bus G3 hot, which is a 12-volt rail that is responsible for making other voltage rails on the system. If we have charger AC OK, that's good news. That means that this whole circuit that you see in front of you is good. And if there's anything wrong with any part of this circuit that you see in front of you, then we're not going to have charger AC OK. Let's go back up to our MagSafe DC circuit. Considering that 3.42 volts is entering pin 5 of U6900, we just eliminated our guesswork, and we are now focused only on a couple of components that could be causing the green light not to turn on. Those components could include the chip itself, U6900, it could include the Pullup Resistor, maybe bad, or it could be the SMC chip itself, system management controller, that is not communicating properly with the chip, and therefore it's not sending the signal to external to tell the charger to turn on. What is SMC, system management controller? SMC is something like a PMU on an iPhone. It's responsible for controlling power on the system, it's responsible for thermals on the system, it's responsible for sleep, hibernate, fan speed, battery charging, when to charge, when to stop charging, and all that stuff. So if SMC is not able to communicate properly with the chip, with U6900, then we're not going to get any signal on extern, on ext, which sends a signal to the charger to tell it to turn on. Right now, what I want to do is test pin 5 on U6900 to see if we have any voltage here. If we do have voltage here, that means our SMC DC AC OK is good. It means that we have 3.42 volts on the system. If we do not have any voltage here, then we go back and we check pin 5 of U6901 to see if we have 3.42 volts. If we have it, then we check, do we have SMC DC AC OK? If we do not have 3.42 volts, then we have to go to the circuit that makes 3.42 volts, and so on. So the process is really easy. It's not that difficult. You just have to follow the signal to see where it's coming from and where it's going to. So right now, let's go ahead and test pin 1 of U6900 to see if we have any voltage there. U6900, let's locate it on the board. So it's a chip that's located near the connector. Let me take you over to the microscope. So pin 1 is on the bottom right. So that's it right here. Now, if you look at the board, it looks like there's some work that has been done on this board before. The customer did tell me that there's work that has been done on the board, but the laptop was working afterwards. It worked for about a year with him, and now it stopped working. So I do not know if this IC is good. I do not know if it's bad, but let's do some testing and see what's going on. We're going to test pin 1 to see if we have any voltage there. We should have 3 to 4 volts here. Okay, this is the multimeter, so you can see what readings we are getting. Pin 1. Oh, my charger is not plugged in. So we have to plug the charger in. Okay. Pin 1. We are getting 3.6 volts. Let's go back to the schematic. We are getting 3.6 volt at pin 1, which is a VCC for U6900. So by having 3.6 volts at this point, I know that we do have 3.42 volts on the system, and our SMC BC AC OK is good. Next, we will be testing our Pullup Resistor if it's a 2K value. So let's put our multimeter in resistance mode. Do we have a 2K reading here? And we have a 2K reading. So our Pullup Resistor is good. So right now everything here is working fine. The only other option that we need to look at is our SMC controller. That could be what's causing the problem. One other signal I want to test before I can say that it's definitely a system management controller problem is test for an SMC Reset L signal. The signal must be present in order for the SMC to work. Let me go back to the board diagram and test for SMC Reset L. I'll pick this point here. The camera, focus the microscope. So we want to test this pin right here to see if we have an SMC Reset signal. And looking at the I'm in resistance mode. Our power is plugged in, and I want to test this pin right here. And look at this, we do have an SMC Reset L signal. So everything checks, and we can definitely say that our SMC is bad. Let's take a look at our SMC chip. Oh, look at this. I see a bulge right here. You see this bulge here? The SMC chip is blown. Right over here. Look at this. So this confirms that our SMC is bad. Right here. Okay, so what do we do now? What we have to do is find a donor board or find a salvage board that we can borrow the SMC chip from. And we have a lot of them over here. We have a lot of boards. A23115 board over here. So we're gonna borrow the chip off here. Right here. We're gonna take the chip off. We're gonna rebolt the chip, put it back on this board, and we should get a green light. SMC is what's causing the green light not to turn on. All right, so that's how you troubleshoot for a no green light on a MacBook. As you can see, we did not have to test every component on the board. We did not have to read all 86 pages of the circuit diagram. Our problem is no green light on the charger, so we have to look at that part of the circuit diagram. This is the part that we should focus on to see what voltages are needed in order to have the job done. Now, by looking at the diagram, we noticed that we should have 3.42 volts present, and we should have SMC BC AC OK present. Since we had both of them present, then we tested the pull-up resistor, and it tested OK at 2 kilo ohms. That's how we narrowed down the problem to being an SMC chip problem, system management controller chip. Now, we're going to be borrowing the chip from a donor board, from a salvaged board I have over here, and we're going to use that chip to put it back on our board so we can get a green light and hopefully get the board working. I have to leave to pick up my daughter right now, but I will be back and I'll try to finish the video today. If not, then tomorrow. I will make sure to have everything on video. I'll either connect the SMC part of the video to this video, or I'll make a separate video to show you how to safely remove the SMC, how to rebuild the SMC, and how to solder the SMC back on the board. Leave a comment if you have any questions, subscribe if you want to see more videos, and until then, I will see you again in the next video.